We've talked about all the different transformations that objects can make. We're going to go a little more into depth. So let's talk about reflections today. And that was one of the first things you saw in your notes from last night. So a reflection in a line, so we have M here, is a transformation that maps every point P in the plane to a point P prime, so that the following properties are true. So we have P and P prime. Remember, pre-image and then image. If P is not on M, so in this case, P was not on M, then M is the perpendicular bisector if you connect P and P prime. If P is on M, then when you do the mirror image of it over that line, it's going to be right on P. So P prime and P will be the same point. Okay, so let's do a little work with this. Graph the given reflection. So I'm going to do a little coordinate grid. So I have my x and y axis. It says to graph the given reflection h22 in the x-axis. So first I'm going to graph the 2, So I go over 2, up 2, and I have h here. And they say to do it about the x-axis. So I have this reflection line here. So that means instead of going over 2, up 2, I'm going to go over 2, down 2 to map that point. And that'll be my h prime. Now let's look at the other example. They have G, which is 5, 4, in the line y equals 4. So now I need to do a line going through the y-axis at 4. So 1, 2, 3, 4. So here's my line, which is y equals 4. So I'm going to put y equals 4 here. And I have G, 5, 4. So I'm going to go 1, 2, 3, 4, 5, and then 1, 2, 3, 4. And I'm supposed to do a reflection on this line, but because it's on the line, I'm going to put G here. Whoops. This is G, and it's also G prime, because when you reflect it and it's on that line, it's the same point. Okay, reflections in the coordinate axis have the following properties. So if x and y is reflected in the x-axis, its image is the point x negative y. So if we look at our h here, we had 2 and 2. And then when we did h prime, we had 2, negative 2. So it matches the pattern. We have a positive x and a negative x. If the xy is reflected in the x-axis, its image is the point negative x, the y-axis. It's negative x, the opposite of x, and positive y. The only reason it didn't work for what we're doing here is because it was right on the point. Okay, let's go a little bit further. So one of the theorems that goes with this, and it's pretty self-explanatory, it just says that a reflection is an isometry because it doesn't change shape or angles or anything like that. Let's look at a real-life example. So we have surveying. 2 houses are located on a rural road. So they're on rural road M, as shown at the right. You want to place a telephone pole on the road at point C, so we would make that point C, so that the length of the telephone cable, AC, which would be A connecting to the telephone pole, and BC is the smallest number possible. Where should you locate C? You can actually do a reflection in order to find this out. So we're going to draw a line M. We're going to go like this. We're going to go like this. And we're going to plot these points. So let's say A is right here. So 1, 2, 3. So we have A. And then B is, let's see, 1, 2, 3, 4, 5, 6, 7. And then up. It looks like it's a little bit higher. Right there. Okay, and we want to put C somewhere so that it's the smallest amount possible between the two. The way you do that is you reflect point A over the line or the road. So we have M. So we go 1, 2, 3. We know it's 1, 2, 3, so we're going to go 1, 2, 3 here. And we have A prime. And I just changed the color. Okay, so what you're going to do now is you're going to try to connect to a point That's going to be the same distance from both of these. And so the way you do that is we have 3 and we go over. We could do it here, we could do it here, we could do it here.